And welcome to Mr. Collins' 17 points for an A+ assessment. Now, hello 7H and 7O. This is recorded live in 7O. Thanks for handing back your progress checks. I'll be reviewing your work and giving you feedback on the following 17 points. Now, for some of you, I've already given you some feedback. Today, I'll be giving you the opportunity to ask me for some feedback in class. If you would like some additional feedback, I'm always happy to help. Let me know. Unfortunately, I have been a little unwell in the last few days, and I wanted to do this video at the end of last week, but I wasn't able to. But I do hope that this is going to help you know exactly what you need to do to get an A+ on your assignment. There's 17 points, and what I expect that you do is rewatch this video and look for each of those 17 points. Don't hand in your assignment until you have completed each of those 17 points. Now, if you do all of those 17 points well, you will be guaranteed an A. So, please watch my video titled Mr. Collins' Draft Feedback for an explanation of exactly what I'm looking for and how that links to the criteria sheet. This is the video. I'm actually making the video right now. So, first of all, in the introduction, it's the first section, have you in-text referenced your work? Now, why is this important? Let's look at the criteria sheet here. If you look at the criteria sheet, and this is the criteria sheet that you've all been given from the start, you'll see that the first point here under introduction is a clear description and in-text referenced explanation of scientific knowledge. See that word in-text reference there? That's under the A descriptor. It's also it says referenced for B. So if you just have a reference list at the end, you can get a B. But if you have in-text references, you will get, for this section at least, an A. Now let's have a look at a B or a C standard. Here's this student's introduction. Now, none of this is one student's work. This is all snippets from probably 20 or 30 different students, and some of it I wrote myself. Now, this student here doesn't have any in-text references. They've tried to down here. You can see they've put a URL link there, but it's not an in-text reference. So it's close. It's a B or a C, but look at this student here. A great in-text reference. In fact, I would probably get rid of the author's first name. A great in-text reference here. They've got an in-text reference here. I'd put a space between that one. They've also got some in-text referencing here, and all of their diagrams are referenced as well. So I'd be able to give them the A standard for in-text referencing. That's point number 1 of 17. Now, do you have information on water quality? Now, when I mean water quality, I'm talking about our 5 factors, and I want that to be quantitative. This student here, the B student, let's just see how that relates to the criteria. Can you see how it says water quality here? So I'll be marking on you. If you have information on water quality, if you don't, you can't get an A. This student here has done a pretty good job. They've talked about TDS, they've talked about pH, they've talked about the acceptable ranges here, but they haven't introduced it very well. Only because I'm the teacher do I know that when they say 150 to 600, that's the acceptable range. Well, this student here, they have very clearly told me what is the acceptable range, and they've used numbers to do so. So I'm able to give them the A for that criteria there. Let's have a look at the third point. Now, here you'll see I need to see in-text reference knowledge about water quality and, what else? Filtration. So I need to know how a water filter works. This is the B or C student. They have started to tell me how a water filter works. They say they've talked about filters here. They've referenced the word filter, but to be honest with you, they haven't really told me how a water filter works. When I look at the A student, they've actually got a diagram of a water filter. They've said words like this. The rocks will remove large suspended particles, dirt, that may carry bacteria. The sand will remove smaller particles, and the cheesecloth will remove the remaining smaller particles. And then not only that, they've actually started to talk about their experiment. They've said 2 filters will be made, one with 1 cheesecloth, and maybe I should say another with 2 cheesecloths. It is predicted that the filter with 2 cheesecloth will remove more TDS, chlorides, pH, and EC for electrical conductivity, but will take longer to filter. And look at their diagram there. So I'm able to say, yes, they've talked about filtration pretty well. Now, point 4, have you discussed your filter, how it works, justifying what change you plan to make? We've actually already talked about that. Down here, they talked about what change they're going to make, and they talked about why they think their change will be useful. This student here hasn't really talked about the change. They haven't really talked about, and this is a big one, by the way. When I've read a lot of your drafts, a lot of you haven't talked to me in the introduction about the change that you made. Some of you included some of you filtered the water twice. Some of you added cotton balls. Some of you added 2 cheesecloths. Some of you substituted rocks for fine sand in the second time that you did it. All of you will have a different change, but you need to talk about it, your experiment, in the introduction. That's this section here. Brief outline of experiment is included, linking to justified research. So not only do you need to outline the experiment, you need to say why. You need to do some research into how a filter works, and I should see that as an in-text reference. Now, point 5 is, have you linked your experiment to the villages? Use data, quantitative, to explain why it's important. That section is down here. If you look at this descriptor here, it says you need quantitative evidence of where scientific knowledge has been used in the real world. Now, most of you will do that in paragraph 3. This student here, the B or C student, has talked about not everyone in the world has clean drinking water. Lots of people don't have clean drinking water. They do have some data here, but it's not a lot of data. Look at the A-level student. They've included a picture. They've also included in-text references, 2.2 billion people, so that's some data there. I would actually like to see a little bit more data. I think they can do a bit more research. Maybe they could talk about what percentage of the world's population doesn't have access to clean drinking water, or they could talk about how many children per day die of preventable diseases because of unclean drinking water. But I really do like that diagram there, so I'd be able to mark them a high mark for that section. So that was point 5. Have you linked your experiment to the villages? If you don't do that, I can't give you a good mark. If you don't link to the villages at all, you can only get a D. So you really need to talk about the villages, but that's point 3. All right. Now the next section is the aim or hypothesis, point 6 of 17. Now, when I'm going to have to skip down to the second section of the criteria sheet. If you want to get an A for this section here, aim and hypothesis, you need to be making a prediction with theory found in the introduction. Let's look at the B or a C student. I don't really need to worry about your aim. We've already given you that aim. But the hypothesis is, they've said filter using clean water will produce better quality drinking water than using dirty water because it doesn't take out substances. That's a little unclear. I'm not sure what they mean there. This student here, though, has said the filter using 2 cheesecloths will perform better and restore the quality of the water to drinking water levels in terms of pH, TDS, chlorides, and EC. And then here's their justification. Here's why they think this will occur. And this is the important part. As more suspended particles, maybe I should say such as dirt, will be trapped in the second cheesecloth. So this student is doing an experiment. They made 2 filters, one with 1 cheesecloth, one with 2, and they think the one with 2 will perform better because more particles are going to be trapped. They've also talked about that in their introduction. So it's not just random information here. I should already know what their hypothesis is because they've already basically said it in their introduction. So that's point 6. Point 7. Are your variables correct and detailed? Now, why is that an important point? Because I'll be marking on that. Look at this section here. Method states how all variables are changed, measured, and controlled. So I'll be giving you a tick here. Now, if you state most variables, you get a B. If you do limited variables, you get a C. If you incorrectly identify your variables, you get a D. So if you do them wrong, a D, some a C, most a B. If you do all variables well, then you get an A. So that's what it is. That's what I'm marking you on. It's important you understand what a teacher is marking you on, and then you can understand how to do well. So let's look at the B level student here. They've actually identified their variables, but they haven't been clear. They've said the water went through more combinations for filter 2. I'm not sure what that means. Now, they're right. What they were measuring, and that's the dependent variable, was how safe the water is to drink, but they haven't been clear. Controlled variables, there could have been more fine sand and more, but that's incorrect. A controlled variable is what you keep the same. Now let's look at the A-level student. Independent variable, the number of cheesecloths. They could even say 1 for filter 1 and 2 for filter 2. Thank you, Maddie.
Thank you.
This video will be available on Central for you, Maddie.
Okay.
Dependent variable. Look, this is what you're measuring: chlorides, temperature, pH, electrical conductivity, and TDS, as well as, and that should be actually qualitative observations. They're controlled variables. They use the same measuring tools: the probe, pH paper, the bottle, the experiment. Maybe they should say the same bottle the experiment took place in. Honestly, they probably need 3 or 4 more. So what else did you keep the same? The same amount of water going through the filters. The same day that the same dirty water source, things like that. Actually, I think this A student needs to do a little bit more there with the controlled variables. So that is point 7. The second thing I'm going to be measuring you on, or marking you on, sorry, is have you justified why you used each part of your filter? And have you justified your change? Let's have a look here. There's the materials list. The B or C student hasn't filled out the, look at that there. They haven't filled out the justification fully. Well, the A student, every single point is very well justified. Also, they've included the initial procedure there. Let's have a look at the B or C student. They've tried this section here, justification of modification. Your modification is what you changed. Now, this student has put the wrong information in here. They've said the sand was the smallest particle contained in the filter, so it was able to trap the most amount of particles. They're giving me the results. I'm not interested in the results in this section. I want to know why you made the change that you did. I want you to justify what you changed, what you modified. Now, this student's done a good job at that. They've said Group 3 thought the most crucial step of impact on improving the water quality is the cheesecloth because it is the final part of the filtration process which provides very fine, tiny particles to escape through holes, which means many unwanted particles will not go through the cheesecloth through the size. The group also thinks that the least important step of impact on improving the water quality is the first step, which is the rocks, because they contaminate the water starts off. So I think this group here, their change was they removed the rocks and they added another filter. And they've justified why they think that is. To be honest, I think they could have been a little clearer with this. I think they could have said that in fewer words, but I understand that they have told me. They have justified it well. And they've also justified what each section of the filter does here. So I can award them high marks for point 8. Now, point 9 is the graphs. Do you have a detailed table? Now, why is that important? Because I'll be marking you on this section here. Construction of an appropriate graph and table as a representation. That's the A descriptor. Look at the B. Construction of a graph and table. Look at what's missing. The word appropriate. That's what's missing. C is representations of data, but not all present. So if you don't include graphs, but do include a table, you get a C. If you include both graphs and a table, but maybe there's a few graphs missing, or they're inappropriately labeled and titled, they don't have the proper title, you get a B. If you have the appropriate titles in your graph and a table, you get an A for that section. I can't not give you an A. And I want to give you an A. I always want to give students the highest marks I can. So that's why it's important that you know what I'm marking you on. So this student here, the B-level student, they've got some decent data. It's a little bit missing there. They didn't include volume, but that's okay. And here, see how this is measuring the chlorides, and they haven't actually labeled that as the chlorides there. Temperature is in centigrades, that's okay, but I just need to see that that's labeled as chlorides appropriately. Now, this group here, a really comprehensive table. Look at all that information. Lots of information in the table, lots of qualitative observations. That's really good. They've also included a picture or a diagram or a photo, so that's really good. And look at their graphs, very clear titles. They've included the units there. They've labeled each, actually that one's wrong, pH isn't in ppm. pH is the only one that doesn't need units. So I might mark them down to an A- perhaps for that mistake. Although because they've got such comprehensive, really detailed information here, I probably will still give them the A. And then the TDS value is good there. So that is the graphs. So that's actually point 10. Do you have 4 to 5 graphs, each with a title, 2 times axes title? You need to label not only the overall title, but the x-axis title and the y-axis title and the units. And I think that was Keanu's graphs I was using there, by the way, for the A standard. Well done, Keanu. Now, do you discuss the pattern of the results? That's point 11 now. Now, why is this important? Because there's this criteria here, accurately states patterns and trends in the data with respect to the hypothesis. Now, actually, you'll find that there's not really a pattern or a trend in the data. Maybe you'll find that filter 2 was always better than filter 1, or filter 1 was always better than filter 2, but for some of you, it's like filter 1 was sometimes better. In some areas, filter 2 was better. In other areas. So, I've put here, this can also be done in the discussion. Now, there's a section called, and let me go to it here, at the end of the results, there's actually a section called description of data. Now, if you've actually described your data in the discussion, you can remove that section, because some of you are telling me the same things in the description of the data as you are in the discussion. I don't need it twice. However, some of you have done that separately, and that's okay. So now we're moving on. See, look at this group. This person here, they've got some really good information. They've said that there is no trend and that the hypothesis is incorrect, but it's only at a B level because do you see any numbers here? No. No numbers. While the A student here has actually put everything in numbers. So filter 1 was 389 ppm for, that was chlorides. Electrical conductivity was 300. I can actually clearly see it. Now, I actually suggest that this student, this is a little hard to read. I would probably add in bullet points. I'd do one bullet point for TDS, and I'd fully analyze TDS for filter 1, 2, and then the dirty water and clean water. Then I'd do another bullet point for pH, and I'd look at the difference there. I also talked to you guys last week about not just talking about the values, but looking at the percentage change. And I'll go over that again today. So you might like to not just say that filter 1 was 389 and filter 2 was worse at 410. You might like to say that was filter 2 was 11% worse than filter 1 or something like that. Percentages are really powerful. But that would be for an A+ level. This student's still getting an A because they've described the results and they've used numbers to do it. And they've talked about the trend. This student did a good job, but they need to use numbers. They need to describe exactly the results, the exact numbers that occurred to get the full marks. So that was point 11. Now we've gone back to the first part of the criteria sheet, the discussion of results. I'm looking for here that you've linked your data to justified research in the introduction. This goes under the analysis of results section. This is the B or C student here. I'm just trying to look for where they've talked about their hypothesis. I'm going to search hypothesis. There they go. The hypothesis was incorrect. Therefore, the hypothesis was incorrect. They've talked about the hypothesis, which is good. Look, that's what I'm looking for. That they link their data to research in the introduction. Perhaps, you know, the reason why they made their hypothesis. But there's no data that they've linked in there. Let's have a look at point 2. I like this statement here. Our hypothesis was incorrect. The experiment was predicted that filter 2 produces better quality drinking water. They've also used information from the introduction. I expect that you would have in-text references here. They've actually said that filtration didn't work. None of the filters produce clean drinking water. And that distillation is a suggestion that perhaps distillation would improve the water quality, making it 100% pure water. Although, to be honest, I'd also like them to talk about, I think if you look at their data, this particular student, and this whole assignment doesn't make sense, by the way, because I've taken different students' work and I've changed some of the words and some of it I've written myself. But the point is that I would like you to go back to your change. You know, why did you make your change? Maybe you decided to filter the water twice. You could say it was predicted that by filtering the water twice, there would be more opportunity for the dirty particles, the dirt in the water to be trapped within the filter, and the water would be cleaner at the end. However, when the water was filtered a second time, it actually became even dirtier. This is perhaps because the rocks and sand in the water were already dirty, and instead of trapping the dirt, actually added more dirt to the clean drinking water. Therefore, the hypothesis is rejected. Now, all that information was information that was talked about in the introduction. So I would like you to use in-text references here and then link your results back to what you talked about in the introduction. That's a trickier point, this one. So something to focus on for sure. Now, point 13, have you discussed at least 3 errors? This is now moving down to this section here. Do you have reasoned explanation for the impact of errors on the reliability and validity of results? Let's have a look at the B or C student here. In the method, there are a few errors. No access to stirring rods. Actually, this is a pretty good job. They've talked about some reasons, several reasons why their results weren't so accurate. I think this is a pretty good standard here. Let's look at the A-level student. They've actually been very clear. They've actually said there are some errors with the different volumes of fine sand, pebbles, and coarse gravel. The table said 1 cup of pebbles, but we didn't really have 1 cup. They've then said the beaker that they used to measure the liquid was not very accurate. What I suggest they do is actually put these in bullet points. There's point 1. Put that in bullet points there. There's point 2 perhaps. Maybe not quite there, but we'll just say it was there to make the video quick. Hello. Point 3 was down here. So we'll make another one there. And do you need to go? All right. Yeah, no, that's fine. That's fine. I'm just recording a video. That's why I was a little bit coy. That's all good. No, it's fine. Well, this video will be up on Central anyway, so she'll be able to take that. All good. Yes, Ryan?
If you have 3 points, do you need bullet points?
Yeah, if you have 3 points, I do 3 bullet points. Yeah. Now, I'm not saying these are the clear bullet points. I was just using those as examples. But I think it's easier to read. If you've got 3 things you could change, have 3 bullet points. If you've got 5 things you could change, have 5 bullet points. Now, what the B or C student didn't do is actually suggest ways to improve the method. So, look at this student here. Actually, the A student didn't do that either. I would have liked to see both students not only describe what went wrong, but things that they could do better. I thought I made the A student say that. Actually, no, they did. Look, this A student said, finally, only 1 trial of each type of filter was performed. To ensure the results are reliable, many more 5+ trials of each filter need to be made and the results analysed for anomalies and an average. So they've actually talked about things that should be changed next time. Some students have talked to me about perhaps we could add in charcoal to our filters, activated charcoal. Some of you have done some research into that. Some of you have looked at distillation and you've talked about how distillation would actually be more useful. That's the section you put this in, things that you can do to improve the experiment. Why is that important? Because you need to explain how modifications, that means something that you modify, something that you change, or extensions, that means something that you do more of, such as more trials, will improve the quality of data. So all of you need to not only identify what went wrong, and all of you have stuff that went wrong. We're year 7 science here, not everything was perfectly accurate. The beakers we use aren't that accurate. I mean, if you say you used 150 milliliters of water, probably wasn't 150 mils, it might have been 152, you know? It's not always clear, and that's okay. I want you to identify those errors. Now, I also want you to identify things that you can do to improve. Now, finally, the conclusion. Let's look at the B or C level student. Do you see any numbers here? No numbers. Let's look at the A level student. Let's have a read. This is a great conclusion. The aim of this experiment was to successfully create a water filter made of limited supplies for rural villages in various countries. The aim was achieved, but the hypothesis was not accepted. Filter 2 cheesecloths, which was predicted to improve water quality compared to filter 1 cheesecloth, was superior in terms of pH, with a reduction of pH from 8.5 to 6.5. In all other important measures, filter 1 was superior, with reductions ranging from 5% better EC to 15% better TDS. Though these results cannot be considered reliable due to errors in the method and limited trials performed, neither filter was able to bring the dirty water into an acceptable range. In fact, TDS and chlorides actually became worse with maybe I should say both filters. It is suggested that water filtration be abandoned and the villagers be given distillation kits to trial. Distillation, in theory, should totally purify the water rather, making it safe to drink and improving their lives. That is a really, really good conclusion there. What am I marking on with the conclusion? Actually, this section up here. It says, clear statements summarizing the findings and accepting or rejecting the hypothesis with valid justification. So I was clear, I rejected the hypothesis, and I justified it with numbers, with data. Any questions? Yes?
When you were at the conclusion, the guy had or the person had a return between the 2 paragraphs. Is that allowed?
Which one?
Oh, you said on the conclusion. It had a
This here?
yeah, there.
That's okay. You can add a return or an enter, yeah. I mean, if it's just like that, that's okay too. But I think it's maybe what they could do is put that.
Oh, yeah.
Because they're kind of explaining now why the hypothesis was not accepted. And maybe they could put a little tab like this. Nope, that didn't work. Like this. Yeah. Anyway. I'll just talk about the last 2 points and then I'll take questions. Finally, down here, you'll be marked on your communication. Do you have clear use of scientific languages? Very few errors in spelling and punctuation. Have you adhered? Are your diagrams labelled? The B or the C student, I don't need to see... Oh, no, it's the A student. Oh, where'd my B student go? Oh, they went here. That's weird. It changed to where it was. They've put like paragraph 2. I don't need you to title the paragraphs. They had a few spelling mistakes throughout. They didn't have in-text referencing. They didn't have any diagrams, and their diagrams weren't labelled anyway. This student had pretty good diagrams which were labelled. Everything was pretty clear. And the final point, though, is... spelling, grammar, scientific language. So no I's, we's, ow. There was a few I's and we's and ow's and the group and things like that. Actually in both of them, so that will need to be removed. But let's look at the bibliography now. Some of you will just put down the URLs. It's not a proper bibliography. A proper bibliography looks like this, with the proper Harvard style, which you can use Cite This For Me to do. So, I know that's a lot of information, but that is the shortest amount of things that you need to change in order to get an A-level assignment. And let me be very clear, if you do all of those 17 things, you will get an A, because this is what the criteria says. Yes?
So if you were to go over the word limit, would it majorly affect your mark?
Not majorly, but it will, because I'll mark you down in your communication. And if you are going over the word limit, I might mark you down on some of the information in the introduction, because I won't be able to give you a great as great of a mark, because I won't say that you've been clear. See how it says clear description? If you say too many words, you're often not clear. So you will get marked down in a few areas, but not every area. Yeah.
Like Keanu said, right? If you have over the limit but you follow those 17 points, will you get marked down or not?
Yeah, well, as I just described,
From like an A to an A.
you'll go for probably 3 to 4 of the criterias. You'll be probably in the B range. But if everything else is in the A range, you'll probably still be able to get an A minus. Now, that said, often students will think they've done everything, and it'll probably end up being more like a B plus or something like that, if you give me a really good assignment. So I suggest, look, if it's your first time, you can make a decision. Do I want to go over the word limit, or do I want to spend a lot of time cutting down what I say, learning how to say it with fewer words, and you'll probably go from like a B plus up to a full A or something like that. So it is important to stick into the word limit, but you're not going to fail if you have over the word limit. At least in year 7. We're pretty nice to you in year 7 about that. You have a question?
Yeah. In the bibliography, do we have to have the link, or can we just have...
Well, you will probably have the link in the bibliography, because if you look at the A-level students, but see how this is hyperlinked? I don't need to see it hyperlinked. That's okay. It doesn't have to be hyperlinked. Just as long as the URL is there. Are there any other questions? Well, I hope this is going to help you, give you some ideas of what exactly you need to do. Not only will this help you in year 7, this will help you on all future science assignments. One last question.
Why is the URL at the top?
No idea, but that's okay. A little mistake like that won't be too worried about. All right. Great.
I have a statement to make.
Statement.
Your discussion on the ACE thing, that was over the word limit. That's
Yes.
far over.
I do agree. That discussion was over.
You
Yeah.
now get a D.
Not a D, though.